12.5, surface areas and volume of spheres. Essential question, can I find the surface area and the volume of a sphere? And can I find the volume of composite solids? In a sphere, it has the same vocabulary as a circle. It has a radius, it has a center, it has chords, chords meaning a segment where the endpoints are on the sphere, and the largest chord, which is a diameter. Also in a sphere, we have what we call a great sphere. When you have a plane that intersects the sphere, if it intersects the sphere in such a way that it includes the center of the sphere, it's the largest circle, and we call that the great circle. The surface area of a sphere is not going to be proved, but the formula suggests this idea. The surface area is 4 pi r squared. And so it suggests that the surface area of a sphere is really 4 circles. And if you think about a baseball, that kind of makes sense because the skins really contribute about 4 circles to make the skin of the baseball. Let's go ahead and find the surface area of the sphere here. So here's the formula. Write down the formula and then write down what the radius is. So this is going to be 256 pi, and this is inches squared because we're doing surface area. Here I need the radius. I don't have the radius, I have the circumference. I do know that circumference is 2 pi r equals 12 pi. If I divide both sides by pi and divide by 2, I get the radius, which is 6. So now I know that this radius is 6, which will allow me to now find the surface area. And when I go ahead and multiply that out, that will be 144, and the units is feet squared because I'm finding area. Let's now find the diameter of the sphere. So this is the backwards problem. 20.25 pi equals 4 pi r squared. So I'm going to divide both sides by 4 pi. The pi's are going to reduce. And then I'm going to take the square root of both sides. And so that'll be the answer is going to be 2.25 equals r. And we want to find the diameter. So the diameter will be 4.5, and the label will be centimeters. All right, let's take a look at how to figure out the volume of a sphere. Let's take a look at a hemisphere, and let's take a look at a cylinder where a cone has been removed. And in both these scenarios, the height of the cylinder is r, and the radius of the hemisphere is r. Now, we're going to use Cavalari's principle. The intersection, this intersection is really a circle, and this intersection is really a disc. It's a circle, and you're going to take away an inner circle. Now, if we go ahead and draw the right triangle where this is the radius and this is z right here, we're going to use the Pythagorean theorem, and we're going to find that this length right here of this cross-sectional area, that's the radius. So this is a circle, this is the radius. I'm going to put it in the circle formula, and I'm going to get this, and that simplifies to pi times r squared minus x squared, or z squared I should say. This is a z, z, z. Okay, now let's take a look at this disc, and we can see that again this is a right triangle, and these lengths are the same, and this is a z length, and this is also a z length here, and over here is a radius. So I'm going to take the area of the large circle, which has a radius r, and minus the area of the smaller circle, which has a radius of z. And if you look at it, this area and this area are saying the same thing. You can just distribute the pi and they're saying the same thing. So this tells me that the volume of a hemisphere is equal to the volume of a cylinder minus a cone. Let's go ahead and put the cylinder formula, which is the area of the base times the height, and the height was r, 1/3, and then here's our pi r squared, area of the base times the height, and then we end up with 2/3 pi r cubed. So this is the hemisphere. Hemisphere means half. So if I want the whole sphere, I'm going to have to times by 2, and I end up with this formula right here. So in our key idea, the volume of a sphere is 4/3 pi r cubed. Let's go ahead and practice this. If I want to find the volume, all I do is put 4/3 pi, get my volume, which is 4.5, and cube it. So let's go ahead and put this in the calculator. And the answer is 121.5 pi, and this will be inches cubed because we're talking about volume. Okay, I'd like you to take a minute, stop the screencast, and see what you can do. And here is the answer. And I can see that I did it incorrectly, and I'm seeing where my error is. I needed to divide this by 2 to figure out what a radius is. So this answer won't be right. Let me go ahead and do that again. 4 divided by 3, and then 45 divided by 2 to the third power. So I'm going to end up getting 15187.5 pi centimeters cubed. So remember, when you're working with a radius, it has to be a radius and not your diameter. So that will be the case. Okay, let's find the volume of a composite solid, and this part is being scooped out. So the volume of the composite is the volume of the cylinder minus half the volume of a sphere. Now the volume of a cylinder is the area of the base. Remember, it is a circle, and it's telling us what our radius is. So that's pi r squared, and the height of the cylinder is 2 minus 1/2 times 4/3 pi, and our radius is again 2 cubed. So this is going to be 8 pi minus, and this is going to be an 8 as well, and so that's going to be 32. Let's see, I can do a little reducing here. So that's 8, that's going to be 16/3 pi, and I can get a common denominator, 24 pi over 3 minus 16/3 pi, and so the answer is 8 pi thirds, and this is in cubic units. And there we go. Okay, here's your try it. Go ahead and stop the screencast, see what you can do to find the volume of the composite. And here's the answer. And I'll leave you with the last screen of circle and sphere fun facts. Taking a look at the circle, which is the circumference and the area, and then the for a sphere, the area, and then the volume.